I'm Anil Kumar, and in very simple language in this video we'll try to understand what are piecewise functions, and we'll also explain the type of discontinuities. So the first question here is, what are piecewise functions? And the second one here is, explain the possible discontinuities for such functions. So piecewise functions, as the name suggests, means a function represented by combination of pieces of function. Function represented by combination of pieces of functions. So in a function we have different pieces. For example, we may have a function. Let me write down this function as f of x, and a part of this function could be linear, and let us say this function, okay, let us try to sketch this here, and then we'll discuss. Okay, so let's say the function is kind of a parabola, which is which is kind of okay, let's say going down like this. So this function, what we have defined, is one piece, and this piece is defined for values which are greater than 0, right? And if I fill this up, I say which includes the point at x equals to 0. So I'm saying that the function is combination of two, where one I've shown like this and the other one I'm showing like this. Let's say a hole here and a line going like this. So these are the two pieces which join together to form a function. So we'll say this function could be defined as like this. We have one piece here which we are saying is f of x equals to x if x value is less than 0, right? So we have not included 0 here. The other piece which we have sketched in red is equals to, let's say, minus x squared, and let's say this point is at 2. So we'll say minus x squared plus 2 if x is greater than or equal to 0. So as you can see here, we have two different pieces defining the function f of x. Do you see that? And we also see that they are not continuous at x equals to 0, right? So these two pieces are defined on the interval minus infinity to 0 and from the interval 0 to infinity. At 0 they are discontinuous. So at x equals to 0 the function is discontinuous. And the type of discontinuity which we have here is called jump discontinuity. Okay. Now we could have many functions with jump discontinuity. Let me take one more, which is very interesting function, and it is called. Let me define this function f of x as equals to the greatest integer function. Now this function is called the greatest integer function. Now it really means that if I have a value, let me write here further, okay, let us say 2.1, right? So the greatest integer value for 2.1 will be, here the greatest integer is 2, so this is equals to 2, right? If I have a value which is, let's say, minus 3.2, in that case, what is going to be the greatest integer? Okay. So minus 3.2 means minus 1, minus 2, minus 3.2. So that means when I'm saying minus 3.2, I am on this point, left side of this point, right? Minus 3.2. Now in that case, the greatest integer which is there is minus 4. Which is on the left side. So the integer on the left side is the greatest possible in this. So you round to the lower one. Do you see that? So what we have here is a function which is kind of like this. Let me sketch this function. Okay, so if I have a value between 0 to 1, let's say this is 1, the greatest integer is 0, so 0 is included and not 1, so it is like this, 0 to 1. At 1, the value is 1, and then it goes like this. So it's kind of a step function. Do you see that? It is kind of a step function, which is the greatest integer function. But if I move to this point, which is minus 0.1, at that stage, the value of this function becomes minus 1. Right? This is at minus 1. For minus 2 in this interval, it jumps and the value is minus 2. Right? This is minus 2 for us. And then at minus 3, the value will be kind of like this. This is a minus 3. So the greatest integer function is kind of like this. Let me label them. This is minus 1, this is minus 2, this is minus 3. Here we have 1, 2, and this is 1, this is 2. Correct? So greatest integer function is also a combination of different functions, as you can see. And this function could be treated as a step function. And it does have a discontinuity, which is same as jump discontinuity. Correct? So this is another example where we may have jump discontinuity, and I have explained a very important function here, which is called the greatest integer function. Right? Now let me take an example where we have different kind of discontinuity. So let us say we have absolute x value, and we are considering a function which is kind of like this. So absolute x value, and we see that at this point the function actually approaches infinity. This point is 1, and I am defining this function on the right side of 1 as f of x equals to 1 over x minus 1. So it is moved 1 unit, where if x is greater than 1, then it is absolute x function. And let me define on the other side a different function. So let the other function on this side be minus absolute x. Minus absolute x if x is less than equal to 1. So minus absolute x will be a function which will be kind of like this. At 1, it is going to have a value of minus 1, right? So it will be kind of like this. At 1, and that will be filled up. Do you see that? That is going to be filled up. So again, we have a function which is combination of two functions. It is again a piecewise function. And the discontinuity here, as you can see, is called infinite discontinuity. Since one of the portion is going to infinity, and this type of discontinuity is called infinite discontinuity. Right? So we have learned about different kinds of infinities, different kinds of discontinuities in a particular piecewise function. However, we could have examples where the functions are continuous also. To give an example, if I have a function which is, let us say, kind of like this, right? And the other function actually starts from here only, right? And maybe let's take a parabola, simple case, maybe like this. So in this case, what you see is that the pieces, both the pieces, they join together at the point where you could expect a discontinuity, right? So that kind of function is continuous. Okay, now as a part of an exercise, what you can do is provide an equation for this, right? And second question which you could do here is write domain and range of the functions which we have just discussed. You may write domain and range of all these functions which you have just discussed. So that should be a very, very interesting question. You can pause the video, answer, and here is my solution for this one. We are saying g of x is combination of two functions. One is to the right of x equals to 0, which seems to be x, right? So let's say x if x is greater than equal, I should not say equal to. Yes, I have filled up this portion, so greater than equal to will work. X is greater than equal to 1. And on the other side, we have a parabola. Let's say this is 2, right? So the parabola has moved 2 units. So we can say minus is going downwards, right? X plus 2, move 2 units to this place, whole square, if x is less than 0. So if x is greater than 0, if x is greater than 0, it is x, right? And if x is less than 0, then the function is minus x plus 2 whole square. So in this exercise, we also learn that if the graph is given to us, we can write down the equation backwards. Is it okay? Now here, domain is all real numbers and range is also real numbers, right? So in this particular case, x belongs to real numbers and y also belongs to real numbers as far as domain and range is concerned, right? In this particular case, what is domain and range? That is really interesting. The part here approaches 0, however the other part has a value 0. The part here has a discontinuity at 1 and is going to infinite value. But actually at 1 we have a value which is also 1 for the other part. So in this particular function we see that the domain range is again all real numbers. Do you see that? So here maybe the function is discontinuous. Still domain and range is all real numbers. That is really interesting. In this case also, domain and range is all real numbers. Since the point origin 0 is included, there is a value 2 there. Domain is all real numbers. However, range is less than equals to 2. So here we can write domain is all real numbers. We could write as minus infinity to plus infinity. And as far as the range is concerned, it is y is less than equals to 2. Is it okay? Less than equal to 2. Right. In stepwise function, we have integer values as domain and range. Do you see that? So here x belongs to and y belongs to integer values. In this greatest integer function, we could write domain as x belongs to all integers and y also belongs to all integers, and we take a greatest integer function. And here, as we saw, x values is x belongs to all real numbers and y also belongs to all real numbers. That's the domain range for this particular function. I hope in this example you kind of get an idea that piecewise functions are made up of 2 or more pieces. We took just a couple of pieces here, and they could have discontinuity, which is like a jump discontinuity or infinite discontinuity, and piecewise functions could be continuous also. We also learned that we could write equations from the function, and if we are given the equation, we can graph the function. Once we are given the equation or the graph, we could always find domain and range of our piecewise functions. I'm Anil Kumar, and I hope that helps. You can always share and subscribe my videos. Feel free to post questions. Thanks for your time.